Factors affecting reaction rate, part 2, the sequel to part 1. So this one we'll look at a more real-life example, a chemistry example dealing with this. But I want you to think back in terms of the seesaw analogy, looking at what the stress is, the automatic response to the stress, which is the opposite of the stress, which way it's going to shift to alleviate the stress, and what increases and decreases as a result. So if we go back here, and I just thought of a made-up example here, a hypothetical reaction. 2 A gas molecules, 1 gas molecule of B in equilibrium with 3 gas molecules of C, 2 gas molecules of D, and heat is released, exothermic reaction. So the way this is set up, we'll be able to look at all of those factors to see what will happen. So just like the seesaw example, what I'm going to do is, once I have what the stress is, state what the immediate response to the stress is, just figure out which direction the equilibrium will shift as a result, and then when it does move that way, what increases and what decreases as a result. Okay? So, first of all, we'll look at a concentration stress. So, adding more B or removing something. So, adding something, removing something. We'll look at the 2 possibilities for each. So, adding more A. So, once again, look at the 4 things. The stress, the response, the shift, and what increases and what decreases. So, if I'm adding more A, if I go back up to the equation here, think of it like this. Originally it's in balance, but if I add more A, it's like I have way more reactants than I need, so it's out of equilibrium. So to go back into equilibrium or back into balance, I would have to move things this way, shift things to the right to get things balanced once again. So if we take a look, the stress is an increase A, the response will be to decrease A, so things will shift to the right in order to use up the reactants and produce more products. So if things are shifting to the right, there'll be more products produced and reactants will be used up. So increased products, decreased reactants. So once again, think of the seesaw and those 4 variables that happen there. Basically 2 options, either adding something or removing something. Okay, if you look at this one, removing B. So removing B is the stress. The response will be to replace that lost B. So if we go back up to the equation here, removing B, so it was in equilibrium, but if I take some B out, some reactant B, I'm short of reactants now. Things will be out of equilibrium. So to replace reactants, I'd have to have the product shift back this way to make it in equilibrium again, or balanced. So shift to the left. And of course, as a result, I'll have I think I have that backwards. I do. So I have an increased amount of reactants. And using up products to do so. Because everything is shifting to the left, replacing that lost B. Okay, so that's changes in concentration. Next thing I'll look at is pressure. So the pressure, and I'll use the word volume there too. Pressure / volume. So if we take a look at a few things, like the elevator example I mentioned, if I have like 10 people in a classroom, and I take those 10 people and put them in an elevator, that is like decreasing the volume that they're in, so there'll be a lot of pressure. They'll exert a lot of pressure on each other. So if you squeeze things together, you increase pressure. Whereas if I take those people out of that elevator, put them in a room, there's more room, more volume, there's reduced pressure. So these are inversely related. If you increase the pressure on something, you're decreasing the space that they're in, or vice versa. Decreased pressure is the same thing as increasing volume. So we'll take a look at increasing pressure, but before we do that, here's a couple of other things I want to mention. Pressure or volume changes only affect gases. They're free to move around, so they're easily affected. And the key part of that is right here. the more gas molecules you have present, the more pressure there is. Okay, so more gas molecules means more pressure. So the side of the equation that has more gas molecules would experience more pressure. So if we take a look at this, so the stress is increased pressure, or I can use decreased volume. The response is to decrease it, relieve the pressure, if you will, by increasing volume. Now, shift to the left. Now, how did I know that? If we go back to the equation here, all we need to do for pressure and volume changes is count the number of gas molecules on each side. So here I have 2 gas molecules of A plus 1 gas molecule of B gives me 3 molecules. Over on the right, 3 C gas molecules, 2 D gas molecules, a total of 5 molecules. So this side will have more pressure, this side will have least or lower pressure. So back up to here to the original question, the stress was increased pressure. I want to reduce the pressure. The side that has reduced pressure is the reactant side from counting up the number of molecules. So as a result, the amount of reactants will increase, the amount of products will decrease, since everything is shifting this way. Okay? And vice versa, if I look at reducing pressure as a stress, the system will want to replace that lost pressure. You can think of it as increased pressure by going to the right. The reason why we go to the right is because there's more gas molecules there. More gas molecules means increased pressure. So it shifts to the right, and if everything moves in that direction, more products will be formed and reactants will be used up. So in the next vodcast, we'll look at the final changes, or the change in equilibrium, and that will be temperature.